So my name is Lavi, managing partner of Vision Elements, and I'm going to talk about our experience with applying sequential optimization techniques into continual learning. Okay, Vision Elements is a powerhouse for computational sciences missions, anything requiring modeling, simulation, or optimization for extraction of information in computer vision, signal processing, deep learning, fluid dynamics, anything AI research. In a nutshell, our talk today about continual learning is focusing how to apply techniques of sequential optimization into the scheme of continual learning during runtime. We'll show how the lightweight nature of those techniques enables to train on edge devices. And of course, we'll focus on not losing memory of already old knowledge or on old tasks. So if we look at it graphically, we have data that we train a model with on the back end, and then we deploy it to the front end to provide predictions based on input. And then what happens if we get new data? So our state of the art is to actually add the new data to the old data and retrain the model and redeploy it back to the front end. What happens if live new data arrives from the field? Then we can have a larger cycle where we add that live new data into our old data, retrain and redeploy, which forms the paradigm of a living model in a way, but this is pretty slow and resource heavy. And continual learning looks at doing that in a shorter term updating, so probably at the front end with just updating the model without going through the whole cycle of the slower and the heavier with resources. Continual learning today is focusing on strategies for retraining, mainly a technique called replay that is actually a mixture of old data and new data, and there are different strategies that you can build for that. And what we're focusing here on this talk is how we can optimize sequentially using a memory term to help that continuation happen on the edge.